Question 2. We've been given total revenue. We are also given total cost. So total revenue is given us 60 kil minus 0.005 kil squared. Total cost is given us 8,000 minus 5 kil plus 0.005 kil squared. A is saying that determine the quantity and price that maximizes total revenue. B is saying that calculate the own price elasticity of demand when revenue is maximized. The C part is saying that find the output level that maximizes the company's profit. D, at what price is maximum profit achieved? E, determine how elasticity of demand is at the profit maximizing output level. So the first question is saying, so you have total revenue, we have total cost. Determine the quantity and price. That maximizes what? Total revenue. Meaning that we are going to use total revenue to find for price and what? Quantity. That's the first part of the question. So A, total revenue. So total revenue is price times quantity. That is total revenue. But we've already been given the total revenue. So I'll just pick it. So total revenue is 60 kil minus 0.005 kil squared. So this is our total revenue function. Now, they are saying that out of this total revenue function, let's find for price. Let's find for what? Quantity. So what we'll do is we use the derivative concept to find for quantity and price. So this is, we find the derivative of total revenue with respect to kil. So this is 60 kil minus 0.005 kil squared. So we find that this is 60 kil. So kil would move this kil out. We have 60 minus the 2 would move in front of the number as I explained. So 2 into bracket 0.005 kil. We subtract 1 from this. 1 minus 2 is 1. So we don't bring it. So we have this. So 2 times 0.005 will give me 0.01. So we have 60 minus 0.01 kil. Since we are finding for kil, we equate this to 0. So this is 0. We make kil the subject. So this is 60. So this is equal to, move this to the left hand side, becoming positive 0.01 kil equal to 60. We are looking for kil. So we divide both sides by the coefficient of kil, which is 0.01, sorry. 60, 0.01, we move this. So kil is equal to 60 divided by 0.01. We have 6,000. So kil is 6,000. So this is so meaning that with total revenue, this is the quantity we are having. So we are asked to find for what? Determine the quantity and price that maximizes total revenue. So we are using total revenue to solve everything. So we now have quantity. How then do we find price? Someone might ask that. Okay, so with the question, there's no price. So how am I going to find the price in the question they are asking for the A part? It's simple. We know the total revenue formula. Total revenue, it's price times quantity. So let's make price the subject of this equation. Once you make price the subject of this equation, it would help us to find price out of total revenue. That's the concept. So total revenue, it's price times quantity. We make P the subject. So this is total. So we divide this by kil. That's by kil. So it moves out. So price is equal to total revenue over kil. So this becomes our price function out of total revenue. Price function out of our total revenue. So now that we know the formula to use to get price, we will fetch the information. We're giving total revenue in the question. So the formula is total revenue over kil. So total revenue is in the question. I'm bringing it here. This is 60 kil minus 0.005 kil squared over kil. This is kil. But take note, this is 60 kil. This is negative 0.005 kil squared. So to make this more precise, what we'll do is don't divide everything by kill. Just separate the denominator. It's still correct, but just separate it. So this is over kill. This is also over kill. So we have price. This scale would move this out. We have 60 minus. This scale would cancel this scale. The kills are 2 here, kill squared. So if the scale cancels the kill, it left with 1 kill. So we have minus 0.005 kill. So this becomes our price function. This is price function out of the total revenue. This is just our price function. Since we now have our price function, we can find for the price in the question because we already know what's kill. So kill was we got kill to be 6,000. We will substitute the kill into P. So this is P. This is 60 minus 0.005. Kill is 6,000. This is 6,000. So we use the calculator. 60 minus 0.005 times 6,000. It's 30. So P is 30. Price is 30. So the A part of the question, determine the quantity and price that maximize total revenue. So this is the quantity that will maximize total revenue. And this is also the price that will maximize total revenue. So the B, we are moving to the B part. The B part is saying that calculate the own price elasticity of demand when revenue is maximized. Let's calculate own price elasticity of demand when what? When revenue is maximized. So I'm cleaning this part. We are calculating for own price elasticity. Okay, so with the B part of the question, with the B part, so own price elasticity. Elasticity is denoted by EPX. This is how we denote own price. So the formula, so EPX is got percentage change or proportionate change in QS over proportionate change in PX. We have to expand this. It gives us derivative of QS over derivative of PX. Whereas so PX divided by QS. Now, I remember someone asked a question saying that, okay, say, now this is the formula I know. What of the Q2 minus Q1 over P2 minus P1 times Q1 over, times P1 over Q1. I remember someone asked a question like this, that why are we not using that? Because this is the formula we know from other studies in calculating for own price. So why are we not using this one here? Now, we are not using this particular formula here because we don't have anything like Q1, Q2, P1, P2 in the question. So we can't use this approach. It can also be used for own price, yes, that's correct. But here lies the case, the question we are dealing with, we don't have anything like this. So this concept wouldn't work for this type of own price. So we use the other type, which is what we are doing here. So let's bounce back to the question. So we'll check if you have PX. They are saying own price in terms of what? When revenue is what? Maximized. So with this PX, QS. So we know PX to be 30. So this is 30. QS. We know QS to be over 6,000. Yes. So now we want to find the own price. We know this side. We are left for this particular side. So how then do we get this side? It's saying that let's find the derivative of QS with respect to what? PX. So what we are going to do is we need to get, or we need to make Q the subject of the total revenue function before we can get our price. So we have this. So I'll pick the total revenue function, or let me do it on that side. Then I'll fix the solution here. So we want to get the side. So that is what I'm about to solve here. So this is the total revenue. It's price times quantity. So now I need to find for Q. I need to make Q the subject of this equation. In order for me to get here, why are we making Q the subject? Or why are we making Q the subject in that particular equation? Because we want to get what? Px out of what? The Qx. So we need to make this Qx the subject of the TR equation. So we divide this by P, this also by P. So it moves out. So Q is equal to total revenue over what? Price. So the simple thing is, let's do this. We have Q is equal to 2, we have this is Q. So total revenue was given us 60Q minus 0.005Q squared. That's total revenue. That's total revenue. That was what we got for total revenue. Now, in terms of price, that's how we solved it. This was PQ. This was over Q. This was also over Q. So we had, let's move this out. We have P is equal to total revenue over Q. Remember that with the price, we pick the total revenue function. The 60Q minus 0.005Q squared. We divided this by Q per the formula. This also by Q. This moves out. We got this to be, this is 60. This one gave us, this Q will cancel 1Q. So we have 0.005Q. So since we even have price for this side, so now this is our price function. And what are we looking for? We need to make Q the subject. We want the quantity function. So with this function here, just make Q the subject. So I'll move this to this side. So making Q the subject. So we have positive 0.005Q. And that's a 60 minus P. So I'll divide both sides by 0.005. That's 0.005. That's 0.005. So this moves out. So Q is equal to, so 60 divided by 0.005 would give me 12,000. This is 12,000. Minus, remember that it's 1 year. So 1 divided by 0.005 will give me 200. So this is 200p. So this is the quantity function we want before we will be able to get the number here. So this is the quantity function. Okay, so I'll bring this function to this side. So let me clean the arrow. So this is Q is equal to 12,000 minus 200p. This is what we have. And this side is saying that once we get the output, which is the Q function, we should find a derivative of this function with respect to px. So you come and look for px or p in this equation. This is the p. Then we now pick the coefficient, which is what? Minus 200, not 200. So this is what we want. So the whole of this is minus 200. So we have EPX minus 200 like this. You already know PX. This is 30. This is 6,000. So EPX would give us minus 200 times 30 divided by 6,000. It's giving us minus 1. So this is minus 1. Now, most people leave it like this. If you leave it like this, it can be marked down because this is own price. Whenever we are dealing with own price and we have a negative number, we always take an absolute value of the negative to eliminate it. So we have this. This is the absolute value. So we now have what? Positive 1, which is what we call the unitary elastic. If it's less than 1, it's inelastic. If it's greater than 1, it's elastic. If it's equal to 1, we call it unitary elastic. So this is how we solve the B part of the question. So I'm moving to the C part. Find the output level that maximizes the company's profit. So the C part is saying that let's find output level, meaning we are still finding Q. So find the output level that maximizes the company's profit. With the B part, determine the quantity and price that maximizes your total revenue. So we are finding quantity and price, but based on what? Total revenue. But the C is saying let's find output level that maximizes the company's what? Profit. So mean with the A we use total revenue concept to get it, the Q and the P. But with the C part, we are going to use our profit function to get quantity. So this is what we do. So output level that maximizes profit. So output level that maximizes profit. So we know the profit function. Profit function to be total revenue minus total cost. So profit is equals total revenue has been given to us in the question. There is it. And this is total cost. So total revenue is 60 Q minus 0.005 Q squared minus, because of the negative in the formula, you open bracket, meaning that the negative is affecting the whole of total cost. So we have 8,000 minus 5Q plus 0.005 Q squared. So we expand this. So this is 60Q minus 0.005 Q squared. The negative would affect everything. So negative times 8,000 is negative 8,000. Negative plus 5Q. Negative and positive is given as minus 0.005 Q squared. So we check, when we get this, what we do next is we check if there's any similarities, if there's something we can add up before we finally say that this is our profit function. So this is 60Q, this is 5Q, we can add it up. So this is 65Q. We have negative 0.005Q squared. We also have the same thing here, so we can also add that one up. So negative 0.005 minus 0.005 give us minus 0.01. So minus 0.01 Q squared. So we are done with that side. The last one left is 8,000. So minus 8,000. So that is what we have. So this becomes our profit function. But remember, we were asked to find the output level that maximizes profit. So we are going to use this profit function to find for what's the output, which is the Q. So we find the derivative of profit with respect to Q. So this is 65Q minus 0.01 Q squared minus 8,000. So we are finding Q. So this is what we do. This is 65Q. So the Q would move this Q out. So we have just 65 minus, remember, the law of indices, the 2 would come in front. So like this, 2. When you become used to, there's no need of you explaining, like just do it straight away. So the 2 comes in front. This is 0.01 Q. Remember, we subtract 1 from it. So minus 8,000. We are dealing with Q. This is just 8,000. There's no Q, so we don't need it. We want Q, so we don't need this. One asks, what of the 65Q? Q is attached to this. That's why we remove the Q and just pick 65. But this is just a number, and we are dealing with what? Quantity. So we don't need this particular thing. So this is what we have now. So this is 65 minus, so 2 times 0.01, 2 times 0.01 would give us 0.02. So we have 0.02 Q. So we are finding for what? Q, because it said output. Output is Q, so we equate this to 0. So this is 65. We move this, so it becomes 0.02 Q. We are finding for Q, so we make Q the subject, 0.02 Q. We divide both sides by the coefficient of Q, which is 0.02. So this is, 0.02. So this moves out. So Q is equal to 65 divided by 0.02 would give us 3250. So we have 3250 units. So this is our quantity, or this is our output. So find the output level that maximizes profit. So the output level that would maximize profit is 3,250 units. So this is it. So we move to the D part of the question. The D part is saying that at what price is maximum profit achieved? At what price is maximum profit what achieved? So what we'll do is we will just pick this profit function. Then we already know quantity to be 3250. So we will fix this Q into this profit function. Then that gives us maximum profit. But this one is saying that at what price? So meaning that we should find for what? The price that maximizes what? Profit. And remember that we already know, or we already have price function. Are you okay? We already have price function. So since we already have price function, we will just come and fix the 3250 in our price function. But if the question is asking for just maximum profit, with that you fix 3250 in this. That's maximum profit. But this is what? At what price? So we want price, but based on what? Maximum profit. And we know maximum profit quantity to be 3250. So we'll just fix the 3250 in the price function. So I'm cleaning the side. So the price function was P is equal to $60 minus 0.005 Q. This was the price function. What we got in the question, there is it. P is equal to 60 minus 0.005 Q. So the D part. Price at which maximum profit is achieved. So we know the price function already. P is equal to 60 minus 0.005 Q. So we know Q to be 3250. Okay, so we just fix it inside. This is 60. 0.005. This is 3250. So P is equal to 60 minus 0.005 times 3250. Give us 43.75. So price is 43.75. So that's the D part of the question. So the E is saying that let's determine how elasticity of demand is at the profit maximizing output. Meaning that with the E part we are finding for elasticity, but we are going to pick all our information from profits. With the B, we were picking everything from total revenue because it was stated. And the E is saying that determine how elasticity of demand is at the profit. So meaning that with the E part, we are finding for elasticity, but we are going to use all our answers or information from the profit side. So I'm cleaning this side. Okay, so we quote the formula. This EPX, this is QS. We have this. This is PX. We have the derivative of QS. Irrespective the derivative of PX. This is PX over QS. So they said based on what the profit. So the profit, what was the price? 43.75. There's it. 43.75. And what was the quantity under profit? It was 3250. 3250. So with that side to meaning we should find the derivative of QS with respect to PX. So we know the Q information. This is 12,000 minus 200p. So we are finding the derivative of this QS with respect to PX. So this is the Q function. So we will come and locate the P in this equation, which is this. We then pick the coefficient. So it's what? Minus 200. So EPX is minus 200 times 43.75 divided by 3250. So EPX is equal to minus 200 times 43.75 divided by 3250. It gives us minus 2.69. That's minus 2.69. Now, as I stated earlier on, with own price, whenever I get a negative number, we take an absolute value. So we now have 2.69. So this is our final answer, not the negative. So this is greater than 1. So it's elastic. So we have elastic demand. So that's all for this particular question, the question 2. That's how we solve it.